So our first problem is going to be x minus... Noah?
Yeah? Oh, we kind of messed up.
Whoops. Before we begin, you'll need to know some vocabulary. An asymptote is a straight line that is closely approached by a plane curve so that the perpendicular distance between them increases to zero as the distance from the origin increases to infinity.
End behavior is the behavior of a graph as it approaches a given number.
The numerator is the divisor of a division problem.
The denominator is the dividend of a division problem. And ice cream is something that everyone likes to eat, unless you're lactose intolerant.
For our first problem, we have to find the vertical and horizontal asymptotes of f of x equals x minus 5 over x squared minus 25.
X squared minus 25 can be factored into x plus 5 and x minus 5. So our problem now looks like x minus 5 over x plus 5 times x minus 5.
You can cross out the x minus 5 in the numerator and the x minus 5 in the denominator. You now have 1 over x plus 5.
Now to find the vertical asymptote, you're going to need to set the denominator equal to 0. Once you've done that, you can subtract 5 from both sides. Then you realize that your vertical asymptote is x equals negative 5.
To find your horizontal asymptote, you take the degree of x in the numerator over the degree of x in the denominator. Since we have no x in the numerator in this problem, we assume that it is 0. So we have x to the 0 over x to the 1 plus 5. So if we take the degree of the numerator over the degree of the denominator, you have 0 over 1. This equals 0. So you have y equals 0 for your horizontal asymptote. You can also use the rule that if the degree in the numerator is less than the degree in the denominator, it's going to be 0. If we want to find the end behavior of this graph, we have to look at the x and y axes. For example, if the problem asks, what does y approach as x approaches positive infinity? What we would have to do is look at the x values of the graph. As the graph moves this way, from negative infinity to positive infinity, otherwise x approaches positive infinity, we look at what y is doing, and we can see that it is actually approaching 0.
Yes, and if we wanted to see what happened to y as x approached negative infinity, going down there, then we would look at the graph and we would see that y is actually moving upwards as x approaches negative infinity. Therefore, and it doesn't stop, therefore, as x approaches negative infinity, y approaches positive infinity. On a quick note, if the equation does not have numbers and instead has variables for it, for example, negative x to the 5th power plus bx to the 3rd plus c, you can just plug in any number greater than 1 for the variables, and you can solve it just like a regular end behavior problem.
Hey look, we found our heads.
Yeah.
Let's assume that Jorge has $2,000 in his bank account. Each month, he spends half of what is in his bank account on ice cream. We can graph this change in his bank account and use it to find out what's going to happen to his money in the future.
Now, every time Jorge spends half of his money, he slowly gets closer to having no money at all. Now, as Jorge gets older, that number gets closer and closer to 0, just as when x approaches infinity. So in this situation, as x approaches infinity, y, the money, slowly approaches 0 also.